So today I'm going to lecture almost alone. So we're going to talk about how to create graphical user interfaces in Python, and specifically using a library called PyQt. So one of the things we're going to discuss is how to implement user interfaces that can run on many platforms, and how to hide complexity of the different platforms. So today we have at least 3 or 4 major platforms. We have Linux, we have Windows, and we have Mac. And all of them have different ways of handling their user interfaces. There is probably a fourth today as well with the web-based user interfaces. And that's another platform that you can also do. But we are going to look at the user interface that you run on your computer directly. So just a little bit how user interfaces are implemented on different platforms. So usually you have an application, and the application is written against a library of some form. So on Linux it's called X11, and it's also called Wayland. There's also a library that is the newest version of that. And then you have the operating system underneath. And if you want to implement another application on a different platform, you do the same thing. You write an application, you choose a different library for user interfaces. On Windows, it's Win32 or WinRT. And you have the operating system Windows underneath that. Then you have the Mac application. You have UIKit, NSKit is the library code too. And you have Mac OS operating system underneath. So you see here, this is not an optimal situation. If you want to write a single application that runs on multiple platforms, you have 3 different libraries to code from. So you have basically 3 different code paths, and that is it's non-optimal. So what we want to do instead is to write to a single library, and in this case it's the PyQt binding, which is a Python library, but it's built on top of something called Qt, which is a C++ library for user interface. We implement user interfaces on multiple platforms. The nice thing with Qt, it handles all the complexity. So Qt can be compiled on any platform, and it has these built-in code paths implemented. So if you're running it on a Windows platform, it will call the Win32 API, but you will never have to deal with that lower level complexity. That is handled through Qt. And because Qt is a C++ application, you need to have a Python, that's called Python binding. That means that it's a binary Python module that is linked with the C++ library Qt. So you don't notice that it's not the Python library or module. It behaves like a normal Python module, but underneath it uses Qt. So what is Qt? Qt is an independent user interface library, and it abstracts all the user interface concepts into a single library. So you don't need to call the native functions for any platform. It also adapts the user interface to the platform you're running on. So if you're running on a Linux machine, it will look like a user interface typically looks like on a Linux machine. Same thing for Windows and Mac. It adapts. But in addition to that, you can also style your user interface completely yourself. You can put style files just like you do on the web to make them your own style. For example, if you run the Spotify application, it looks like Spotify on all platforms. It has a black window and its own custom design. And that's something you can do with Qt as well. And then the events, when you click on the mouse, type on the keyboard, move the windows, is handled through a special system called signals and slots. That means that you connect a virtual cable between the button and your code. And that is the button sends a signal, and you connect it to a slot in your code. So that is kind of how you handle the events of the application. I already covered this a bit. So Qt is a C++ library, and binding is a special module that is compiled with Qt. Unfortunately, there exists a lot of Python bindings for Qt. So you have PyQt5 and now also PyQt6, PyQt4, and then there's something called Qt for Python, also called PySide, Python Qt. We will use PyQt5 it's not really, you don't have to explicitly call Qt5, we'll come to that later, but it's when you install the module, you'll likely have PyQt5 installed. So, event-based programming. So, up until now, you have run your code, starting with the main routine, it executes in steps and finishes the execution at some point. Now we are going to change to something called event-based programming. And what this is about is that you have, instead of having a point A to B execution, you have something called an event loop. So the application is always running in a loop, waiting for events to happen. And at some point you click file exit on your window and the application exits, and then the application closes. So the event loop waits for the messages, and there can be keyboard, mouse, system messages. And the event loop is responsible for dispatching the messages to your code. So when a mouse press occurs, it is passed along to your application. And the loop only exists until the final window has been closed. So when you close the final window, it will exit the loop. But this is a pseudocode. For example, you set the flag while running is true, and then you have while running, a check for events, and then you go in if event is button click, then I call some kind of routine to handle this button click. And then you have a lot more checks here, and then at some point you have if the event type is application quit, then I set running equals to false, and then I exit out. You actually never see this code yourself. So it's embedded into the Qt library. So you basically call a routine that goes into, starts the loop, and that function exits when the loop exits as well. As I said before, there are many bindings for Qt, and that makes it a problem when you're starting to code. So one way of avoiding it is to use something called QtPy. And QtPy is not a library in itself, it's more a translation library. So if you import QtPy, this library will check which Qt is installed in your system, what modules you have, and will act as a layer in between so that you can basically run your program in Qt5, Qt6, PySide. It doesn't matter, it handles that checks. So using a single import, you can support multiple Python bindings. You will see in my code examples, all my import of Qt is using QtPy. So let's start with the first main program in Qt. So we have import sys because we need to do, this is the convention as well, that the exit application using sysexit. And so when your application exit, it returns a numeric value. If everything is okay, the value of this function is 0, and then it returns exit here. And then you can check if the application started correctly. But the first thing you do is from QtPy widgets import star. So QtPy here is the translation layer. Qt widgets is the main module in Qt for the user interface controls. We have a main program here. The first thing we have to do is create an application object. And you will see here, there's a lot of object-oriented programming here. So, and user interface design and programming is very much suited for object-oriented programming. We create an application object. We pass along, this is the arguments to when you call a program. We don't use it so much, but we have to pass it along here. You get back an application object. And that is your, everything you need to run your application is contained in that application. It's not a window itself, it's just a mechanism of running your application. Next, we need to create a window of some sort. And the base window in Qt is something called QWidget. There are some other ones that's very specialized, but this is kind of the minimal thing you need to do to get a Qt application running. You create a widget to get an object here. And then you need to show that object as well. And you do widget.show. But if you stop here, nothing will happen. The window will appear, but you can't interact with it. Because for a user interface application in Qt to work, you need to have a loop running. And the application loop in Qt is contained in the application object and a method called exec_parentheses. Here it goes into the application loop. and it never exits until the final window has exited. So I will show how that looks here as well. I think it was EX1. So here I have my same application again. So if I run this, you can see here that I get a single window here. There is nothing to interact, but already now the application know how to, you can resize the window, you can move the window, you can make it bigger, maximize it. All that is part of the application loop. So what the application does now is just manage a single window. We don't interact with it at all, we just, it handles the display of the window. And you can see here now, if I look at execution here below, you can see here that the Python interpreter is hanging here. So it's running in the app exec function. And if I close this window now, you can see here that we are off to exec. So it goes into the application loop, and the print statement here is only executed when the final window has been shown or closed. So that's the main Qt program. Yeah, and then QWidget is the base of all the classes in the Qt class library. So most of the other controls that you can interact with in the user interface derives from this QWidget. And it has the base functions for setting the geometry of the control, the window, and so on. And it can also own other user interface objects. So you can add, each widget can have other widgets that it owns and displays in the window. And if there is no window, as we just created a QWidget, it will create a window around that object. So what we actually saw was the gray area was the kind of the widget we are displaying. But if there is no window, it will display a window. But what you usually do is that you derive your own application windows from QWidget. And here you can see some of the, here you have the QWidget is top class. And my window here is the one that I'm going to create here for my application. And it inherits all the functionality of QWidget. And then I just specialize it here by adding other controls to my window. So I have a line edit for entering text. I have a label for having a static text label. And then you can add more hierarchical controls using QGroup. And then you can have more controls under that as well. So let's add some methods here to this. So now we are going to create our own window. So we have my window here. This is my own class. I derived that from QWidgets, of course. So this will have all the features like resizing the window, redrawing and stuff like that. The background is built into QWidget. The first thing I do, I call the super init here to make sure that the QWidget instance is initialized correctly. And in this case, sometimes it's good to put all the user interface code in a special method. So I have this here, init GUI, and then I have my own methods here inside here. So what I do here is that I set the size of the window, size and position. So 300 by 300 is the X, Y position, and 800 by 800 is the size of the window. And then there's a method called setWindowTitle that sets the window title. And then to kind of display it automatically, I do show here. Then I don't have to call it when I create the window. It automatically displays. And here you now can see that I create my own window. And then I go into my loop here. So there's not much difference in this example here for... the only difference is that you can see that I'm positioning the window here, and it's 800 by 800. And you can see the title has changed as well to my window. Yeah, and the main program has also changed a bit, but the only difference is here that we call our own my window class instead to create that. Then we need to kind of interact with the application. That's kind of the point of user interface application, to have buttons, controls that you can interact with, and also to connect to your code. So the first control we're going to look is the Q push button. That is a normal button here, and what you do is to create it as an attribute to your class, and that's important. If you create controls that you want to interact with later on in your code, they should be owned by your class, my window class. So in this case here, I put self here, and then I can refer to them later on as well with the name here. If you only have like static controls that you don't need to interact with, you can just create them here and add them to the window. You don't have to have self in front of them. So the parameters to Q push button is press me, that is a string, and then self here, that is where it should be attached to. Who owns this object? So in this case here, self here is the window, and then so the button is attached to the window. And then I call resize here to set it to a certain size. I move it to 50 by 50. I just show the window here again. So if I go back here to my example, you can see here I have my push button here. And then I have my geometry settings here, show, like that. Oh, this was really small. Let's see here if we can have some stuff. So I have a button here, press D, and you can see here that without doing anything, you can see it interacts with my mouse, and it has a hint window, and I didn't have to write any code to do that. That is built into the object that I added to my code. And the reasons why I added this times here is because the screen I'm using now has, just like a Mac, very high resolution, and you need to tell Qt to scale application up a bit. And that's why I added these two. So that added a button to the window. Of course, a button is kind of completely useless if you don't add connect them to your code. And what we are going to do is we're going to connect the button to signals from the button to my code. And there are different signals that you can connect from. The one for a button, which is kind of the most used, is the .clicked signal. That means that it's a complete click. So when the user has clicked and released the mouse, that is a complete click. You have also the pressed here is when the button is held down, and that will call that. And then there is also some other, for example, in this box there is a current row change. So there is a lot of these signals, and you can find them in the PyQt documentation. And how you connect them to your code is using something called the connect method. So if I want to connect my button here to my code, I take my button object here, go to the signal clicked, then I do .connect, and then just give it the method I want to connect it to. So then it's there is a connection between an event and your code. So let's go to this to here as well. So what I have done now is that I have created a button here, button object, and then I connect the clicked signal to on button clicked. So on button clicked is a method in my class, and the only thing it does is just print hello. So when I click the button, it should print out hello in my terminal window here. So let's run this. So if I press this one here, you can see here that down below here it says hello all the time. So now we have made a connection between the user interface and our own code. And the key to remember here is that you need to select the signal you want to connect, and then use the connect method of that signal to your own code. And I usually, to distinguish my methods that are not responding to events, I usually prefix them with on underscore, because then it's clear in the code that this is something that is called from an event. An event is calling this method on something happening. So a normal method that I'm calling inside my code, I don't put the prefix on. Only for those that are connected from the signals. And there is a lot of documentation here. The documentation is for C++, but it's very similar to you have modules. So you can see which signals they send and which parameters you have to add to your event method to connect it. Then there are some properties on the widget controls as well, so that are similar to all QWidget derived classes. So for example, you can use setVisible and isVisible. So setVisible will hide the controls. It will not draw, it will be invisible. And you can check the state of a control by using the isVisible method that will return true or false depending on the visibility status. Another important useful feature is the setEnabled method that can disable controls, because you want to, when you program user interface, it's very important that you program defensively. And if something that you execute with a button is not available at that time of your code is running, it's better to disable the control. The user sees that it's still there, but you don't have to encourage them to press. For example, if you have results in an application and you haven't done your computation, you can disable the show results button. It's still there, but it kind of tells the user, okay, it's not available right now. You can check the status there with isEnable as well. Set focus is mainly used if you have text input, or that you related to most related to text focus. So if you have multiple text boxes on your user interface, the cursor can only be in one of them at the same time. But if you want to set the focus to certain control when it's shown, you can use this to kind of give the cursor set the cursor in that control. Most controls also have an ability to set a descriptive text, and that is done with the setText method. And if you want to get that text, you use .text. And we will use that a lot when we get the data from the user for the parameters, for example. You use the text method to get the text and then convert that to a floating point. So let's see here. So in this case here, we just look to. So we have connected two buttons here, three buttons. So we have press me on all of them. They are next to each other. And then we connect the first and second button to some methods here. And what we're going to do is we're going to try the setVisible and check for visibility of the control. So if I click the first button, it will first check if the second button is visible, and then it will set visible to false. Otherwise, it will set visible to true. The same thing with button 2 here. We'll check if it's enabled. Otherwise, we set enable false, set enable true. So let's see here. We have three buttons here. If we click this one here, the second one disappears. So visible actually makes the control go away. And if you press it, it goes there again. And you can see here the third button now is I can click it, but if I click this one here now, it's disabled. There's nothing happening here. You can't even, it will not receive any events in that state. Now it will again. So this is a way how you can design your user interface to be convey information about the state of the program by using setEnable. It could also be that some controls should be invisible. You can have a group of controls that's only available if in a certain state of the program. Then you can set the entire group to visible false and visible true. Skip that one. Yes, then we have also, now this is very system independent, but you can also set the style of the window. So the default style is a resizable window. You can drag it and move it and resize it to your heart's content. In some certain situation, you don't want the user to be able to resize the window. You have a dialog that is fixed with a certain controls in it, and you don't want them to resize it. Then you can set the style to dialog here. There is also a third style called Qt tool, which sets it to be a small tool window. Then the top bar is a bit smaller, and that is dependent on the operating system as well, how that is implemented. So go to Windows style. You will access all of this code is available as well, so you can experiment with this yourself. So let's see here. I have the normal window. Looks like this. We have seen it before. It's just, you can resize it here. It has a minimize button, a maximize button, and a close button there. The dialog window, there's also a special dialog class here, but you can also set the style to be a dialog as well. This is what to do here. So now you can see here, it looks a bit different. I have a close button only. It's still resizable in this case here, but and then I don't have a minimize, and I have a help function here for the dialog. And then I have also a tool window. You can see here it has just a small caption on the top and just a close button. So this can be, for example, a floating toolbar with controls that you can have on top of your window that the user can access quickly. You can also change how the window should appear on the screen when you start. For example, if you want an application to take up the entire screen, you can maximize the window. And it's the same thing when you press the maximize button in Windows, but you can control that programmatically as well. So in this case here, I can set it to start with window maximized. Then if I run the application, I have to stop the... So maximizing the window will bring up the window to cover the screen, but you still have the top window bar, and you also have the resize button here as well. So that's the way you can start an application to cover the entire screen. There's another one here which is a bit more dangerous. It's window full screen. Then you will the window will cover the entire screen, but there is no controls. So, for example, if you want to program a game, you can set Qt window full screen, and then you have the entire screen estate to work with. It could be that you create a user interface for some kind of public kiosk system, then you want to have it full screen. So if you run this one here, you can see here now there is no control. The window is all over the place. So how do you get out of that? Then you do Alt F4 to close the window. So it's a bit dangerous because there is no clear event how you close the window. Another thing that is also important when you do user interface is to be able to create a menu bar. And the structure of classes for doing this is you have a top level menu bar. That is the menu bar on top of the window, or on a Mac you have the top on the top of the screen. And then you add menus with menu items on underneath. And here is a special thing that we do for menus and toolbars, is that you have something called a queue action, and that is what is shared between a toolbar and a menu. So instead of duplicating the events between the toolbars and the menus, you connect your code to the action instead. And the action is executed from a menu or from the toolbar. I will show that later here. So the first thing when we do create menus is we create an action first, and that is what you want to perform in your application. So for example, in this case it's just called my action, and then you can also set what keyboard shortcut that is going to trigger this action. So in this case, if I press Ctrl T, this action will trigger. And then you do, the action has a signal called triggered, and that can be triggered from a menu click, from a shortcut, or from a toolbar. It's the same thing, but you connect it to your code. So I have an on my action here that displays a message box. So now in action, now I have to create a menu. And if you have here we instantiate a special class called QMainWindow instead of our QWidget. And the main window, the difference is that it knows about toolbars and menus. So it has a function called menu bar that returns the current menu bar, and we add a menu called file, and we get the menu object back, and then to the file menu we add action. So let's see what happens when we run this. So now you can see here we have a window, and there is a file menu here, and we have an action here. So this is what. So if I click here now, it will show the message box. I can also press Ctrl T on my keyboard, and it will also trigger the same event. So it's you create all your actions in your application, and then you connect them to the menus, and in the next step we will connect them to the toolbars as well. So you can see here that you can have, there's a method called add toolbar. You get the toolbar objects back. You can give it a name, and then you attach add your actions to the toolbar here as well. So just like a menu here, but now you have a toolbar. You can see here that I got the toolbar in my window here as well. So first I create menu, then I add my toolbar here. Okay. Let's see if it looks better now. Yes. So I have my window now, and you can see here it adds a toolbar automatically to my window. And you can see all this functionality for the toolbar is already built in. So I can actually drag my toolbar around. I can drag it outside my window. I can dock it left, right, on top, and on the bottom if I want, like this. And if I click the action here, you can see I get a message back. So the actions stay the same. The toolbars, you connect the menus and toolbars to the actions. Just going to update this one here as well. So this is a bit more complicated example. You can see here I have. So this is how you can define your complete application. You start with defining everything that is going to happen in the application that the user can call. And here you can also see that you can connect icons to the actions as well. So if you have a toolbar, it will display the icon in the toolbar as well. And also in the menus, it will display the same toolbar, the icon in the menu as well. Shortcuts, you connect to your methods here. And you go through everything that you want the application to perform. And then you create the menu. And then you create, in this case, a file menu. And I add the file actions to the menu here. Add action, add action. Add separator, we create a line in the menu. So you can group the different things in the menu. Add action again. And then you have next edit menu. Add my actions. And then I do the same thing here for the toolbar. I have two toolbars. I have a file toolbar and I have an edit toolbar. And then I show it. And then you can see here all my event methods that are connected to it. And if I run it, it looks something like this. So now I have two toolbars, one file toolbar and edit toolbar. I have my menu like this. And you can see here that the icons appear on the menu as well. like this. And I can, if I want the toolbar here to move, I can move it here. And that is kind of built-in functionality in this application that for this widget, they implement all this automatically. And you can see here, I can save, I can close. Those will also connect to different methods here. Also, just to note that if you want to exit an application, you can do self.close. So that will close the application and exit the application loop if it's the last window. So next, also up until now we have placed the controls using X, Y, and coordinates and the size, which is called absolute positioning, and that can be problematic in certain cases because you have to manually change your controls. If the user resizes a window, the control stays in the same position, and you just add more space to it. So what we usually do in Qt is use something called sizers. And sizers are specialized classes that places controls in different ways. So it can be horizontally placed, you can have it vertical placed, you can have them in a grid shape. I will go through them here. So we start with a simple form. It's a vertical box sizer. So what it does is it takes controls and places them vertically. So you create your buttons like this. You don't give them any coordinates, anything. You just create the controls and then just put them in this bag called VBox layout. And then you, on your widget here, you set the layout and you give it your box of controls. This is the simplest form. You just have one single layout with all the controls like this. So let's go for, let's see. So here I have my buttons 1, 2, 3, and 4. I still put self here because I want to, later in my code, be able to reference them, and then I have the self put button that I can get back to. If I just created the buttons without the self, it will still work, but you will never be able to refer to them again because they are owned by the window, but there is no direct reference to it anymore. So that's why you should put self on everything you want to be able to manipulate. And then we add them to the box layout, set the layout of the window like this. And what this box layout does is if I resize the window now, it will distribute the controls like this. And also if I try to make it smaller again, it will compress. But there is a limit. So there, all the controls have min sizes and max sizes that you can't shrink them more. And if the layout manager hits those, it will stop. There is also margins here around that it can't shrink more than that. So it's important that you kind of, but this is automatically handled. Same thing here, if I do this way, the buttons get wider. But there is also a limit on how small they can get. And you can have, of course, horizontal box layout. And then it's the other way around. So you go in the horizontal direction instead. And it's the same syntax here. So instead of doing a V-box layout, you do a H-box layout, add your widgets to it, set the layout. And then you get this, it looks like this instead. And you can see here that it also has this, the buttons have minimum sizes and you can't go shrink them below that. And then the entire layout is prevented from getting smaller here. But larger you can do. Same thing, it places the control in the middle of the window like this. Then you can combine these two different things. So my advice to you is that when you design your user, do it on paper first. Take a paper and paper, what controls do I need? How should it be layout in the window? And then implement that later. Because if you start coding directly here, it's a bit complicated to get it correct. So in this case, I'm going to want to create a window that has 4 vertical buttons like this, And the fifth row will have the buttons on the horizontal direction. So I have an outer vertical box. So you can place layout sizers inside other layout sizers. So outer box and inner box, and that is a H box. So you can see I have 8 buttons. The first button I put in the vertical box control. Then I create an H box control where I do I add my other buttons to this one, and then I add I'll skip that one here, and then I add a layout H box after here to my V box layout. So first I have my buttons, and then I have a H box layout as the final one in my vertical box. And then I set the layout of the window to V box. And if I run this, you can see here that I get something like this. It's a bit small. And if I resize this, you get this kind of effect that they stretch out. And perhaps you want some constraints here. I want the buttons to be on the top, and this final row should be on the bottom. And you can do that by adding something called stretch. And the stretch is like a spring. I will show when I do how you can use a design tool for this. There are springs that you can attach, and the springs will expand and push the controls like a magnet. So if I run this here now, and I resize it here, you can see here that there's a virtual spring between button 4 and the lower layout size. So it pushed that below. You can of course do that for the top ones as well. So now I put a stretch between the button 5 and 6 in the lower part of the controls. So let's see how that works. So if I stretch now here, you can see here that I have a spring between button 5 and button 6 that pushes them apart from each other. So in this way you can create really flexible user interface layouts that scales when the user changes the window. Let's see if a little bit better like this. And a little bit bigger. So like this. Yes. And finally, before we take a short break here, there's a grid layout as well, and that is a slightly more flexible layout. And in this case, you give the controls a row and column number, not a coordinate, but a coordinate. So in this case here, I start 0, 0 here is the top left, and then I have 0, 1 for button 2, that is the second one here, and then I place the layouts like this, and then you can also add stretch things to this as well. So let's go to grid layout. We'll add this. So I just create my buttons here. I have 9 buttons here like a calculator. I set the size policy here that they should expand. So there are many policies you can set how the control should behave. And then I add my widgets to my grid layout. And you can see here, every time I add, I also specify a row and column for the control. And here you can also set the contents margins, is how the spacing between the controls. Vertical spacing, that is top and bottom, top and left spacing. And then you can set stretching here as well on the different columns. So in this case, I have on the column 0, I have 1. It's just a number that gives the relationship between the stretching here. So in this case, the first column will stretch in the 1 unit, the second 4, and the third will be 1. The same thing here on the bottom ones here. And then finally, I set the grid to the window layout itself. So if I run this, so you can see here I have 9 buttons here now, and if I stretch this now, you can see here that the stretching here is that this is 1, 4, 1. But it kind of maintains that ratio. Same thing in the rows here, 1, 4, 1. And then you can also see that there's lots of spacing in between them, and that is controlled with so this here, contents margins. If I set them to 10, 20, 10, 20. So you can change the how they are placed here. And then you can also change the horizontal spacing here, so you get more tight layout like this. And in those buttons doesn't have to be buttons. They can also be groups of other controls. So you can have, for example, say that this middle button here is a text edit control. Then you have some buttons here to the left and right to control the different views here. So it's just the buttons here just for illustration. Okay, let's take a... Yes, so finally I want to go through some standard dialogues that are part of the library as well. And standard dialogues are user interface controls that are simple, easy function to call to display a message, to select files, to select colors, and so on. So they are built in the operating system, and you can bring them up through some functions in Python as well. So how you call them is that you have there's one module called QMessageBox, and you never have to instantiate object here. You just call the method on this object itself. So in this case, you have an information message, and that is what you see here. And it looks different on Windows and Mac, and it adapts to the user interface. So it doesn't call its own method for displaying it. It calls actually the operating system's dialog boxes. So I will show them here. So I have created a menu here to display them, and in here you can see here I have a Q message box. It says information. Self here is the owning window, so you always have to attach the message box to an existing window. In this case, cases are my window class here. Running this, I select File, Open Dialog, and you can see here that I get the message box like this. Let's see if I can get this bit better. Should I add those here? It looks better now. Like this. And then you have, let's see if we can fix the other ones as well. Dialogues 2 here, this is the information is the kindest message box. Then you have critical, which is the worst one. Is if you have something really goes wrong in your application and you really wants to inform about the severity of the state of your application, then you can use the critical one. So if I run this, it looks like this. And you get this red box. And if you have a Mac, you get a different one. It selects depending on the operating system. And then you have, finally, you have there is one called warning as well. And you get the triangle here. And which one you use is depending on the severity. And I would recommend using informational as much as possible. Critical is kind of intimidating to get, when you often get the signal as well with a sound effect, which is I think you should avoid that. Another dialog box is that you can ask a question. So quickly ask a user, do you want to save? Are you really sure? Or something like that. And that is done by the question function of the message box object. So here you can see first you create the question and you give meta, and that is the title of the window, and then the question, and then you have which options you want to provide the user, yes and no, and which one should be default. In this case, no is the default. And then the result is what you get back from where the user has selected the message box, and then you can take action depending on that. So in this case, if message box yes, then do this. So you can see, do you want to remove a file? Yes or no. So you can see here that it's difficult to see, but no is highlighted. That is the default. So if I press enter or something, it will always select no. So you need to take an action here to actually yes. So this is quite, here you don't have to implement your complete window yourself. You just call a function, it displays a window, and you're done. Another dialog is very common, which you will use in this course, is the file dialogs. It's to kind of ask the user for a file name on your computer. And then there are two ones. There is one called get open file name and get save file name. So open and save are different dialogues. They have a different functionality. And what you do here is that you do qFile get open file name. It returns two parameters. The second one we can ignore, so we put an underscore here. If the user cancels the dialog box, it will return an empty string. So we can check for that. If it's not empty string, it returns the complete file name with the search path to the file. Just modify this directly so I don't forget. So here you can see I have file name, get open file name, and also this second parameter here is the filter option. So you can select which kind of file it should filter out. So in this case, it will only display INP files and no other files. This is the title of the dialog. You can also give it a default file name if you want. In this case, we just give an empty string because we don't have a default here. File, open dialog. Now you can see here, I'm running on a Windows machine, so I get the Windows standard file dialog. If I'm running on a Linux machine or Mac, I get the corresponding system file dialogs. And you can see here now, the directory I'm running is completely empty, which is not true, but you can see I can only select INP files. If I want to select all files, I have to change this here to star, for example. And now you can see I can select any file in that directory. So if I select here, press open, you can see I get back the complete search path for this file. And if I would have just cancel, I get an empty string. So in that way you can, in this statement here, I can check for if I selected a file or not. Save dialogs are the same, but the other way around. So here you want to you ask the user for a new file. So save file name. So here I can select a file that doesn't exist. So test. And here, if I don't give any extension here, the dialog function will automatically add the extension INP to the file name. So if I do like this, you can see here I get the directory which is selected, but test.inp. So it will automatically add the extension to the file. So with a save file name, you can ask the user for a location of a file. It doesn't create a file, but you get a complete location. With open file name, the file has to exist. So just quickly go through some of the controls that are available in the toolkit. So we have covered the push button. I will come through it quickly here, but another important control is the checkbox or radio button. So these are buttons with state. So it's like on-off button on the wall. They can have a state. They can of course be enabled, disabled. The checkbox you can check the state or set the state with the set check state method, and you can check the state with check state. The radio button can also be checked with set checked is checked. And the difference between checkbox is that checkbox, you can have multiple checkboxes, and you can have any of them can have a check or not. With the radio button, only one of the radio buttons can have the state in a group. So if you select one of them, the other ones will be disabled. And what you need to do with radio button, if you want to have multiple radio button groups, you have to group them in groups. Otherwise, they don't work. It's only one of them will have the true state. So let's go to... So checkbox here. I set the state when I run it here to true, so it will be by default checked. There's a signal going out, so if you check or the user clicks on checkbox, it will trigger the state change signal, and then you can connect that to state change. For checkboxes, you really don't need to connect them to events, because you often want to query them at some point, but you really don't know if there are some certain when you want to do it, but most of the cases you can just have them as controller and query them when you need it, and not have them queried when something changes here. But I show you here. So it's connected change, and then you can use check states to see if it's checked or not. So you can see here I have a checkbox here. It's checked. If I click here, you can see here that it's the state change method is called, and here you can see it changes the extract. And we have radio buttons. And here I have created two buttons here, 1 and 2. And then I connect them to my methods here. And you can the same thing here. You set checked on one of them. The other one is automatically unchecked. And here you can see you use the same method to is checked to check the state of it. So I have two ones here. So now the first one is true, but if I click this one here, the second one goes to false. So only one of them can be selected at any time. So this is kind of for optional selection, that the user can only select one of multiple options. It's a very common control in user interface design. Combo box is a bit same here. It's a multiple selection control. Can also be a text box where a user can select from a limited set of options. And the reason for using a combo box is if you have a limited space in your user interface, instead of using radio buttons that take up space, you can use a combo box that takes just single line, and it drops down a menu where you can select options. It has a signal called current item change, which is when you change something, it will call this signal. There is a function that you can get the current index of the selected item using current index. So let's go to combo box. So we create a combo box just like this. We don't give it any titles here, just give it an owner. I just place it somewhere, add items to it. So I have 4 items. I set the current index to 3, so 0, 1, 2, 3. So the item C4 should be displayed as a default selection. I connect the current index signal to my method here. and just display what actually happened. You can also see that I can query the text. So what actually is in the selected text here is also available from the current text method here. So you can see here, if I drop down, you can see I have all my controls here. If I select one of them, you can select a 0, and the text was alternative 1. Slider is a value control where you can very easily move a slider to select different values. You can select the range, and you can also make it fixed positions on a scale. The only thing is that it's integers. So if you want to have floating point, you need to figure out a way of converting integer fixed values to some kind of floating point value. Slider. So you can create either vertical or horizontal sliders. I can set a maximum value, a minimum, and a current value. And then you can also connect value changed signal, and I connect it to my own. And then I just print out here the values of the slider here. So let's run this. So if I slide this one here, you can see here that it displays the values here if I change it. List box, similar to a combo box, but it displays all items in a box of a certain size. You can add scroll bars to the control, so you can have a large amount of values in a single box, but the user can move around with the scroll bar. It can also support multiple selections, so you can have the user select with control multiple items in the list box. So I created it basically the same way here, like a combo box, but it's a list widget. And I give it a size here as well, because it's not a compact control. It's meant to display the items in the box. And I add 100 items to the box. I set the current to 2. And also current row changes a signal if you select something in the list box. And then you can see current item here is the current value you selected. You can also select here, when the current row changes, it has a second parameter here with the selected item. So you can see here I have 100 values, so I can scroll up and down. I can select something here. And you get also the text back if you want, like this. Line edit is one of the controls that we will use a lot in this course. So, and it has basically two methods: set text and text. So set text will set the text. Text will retrieve the text. So it doesn't handle value. So all value transforms you need to do yourself. Go from text to floating point. It's something you have to do manually in your code. And you also have to check that the do some error handling on that as well. So let's see here, line edit. So what I do here, when I press the button, I will display the text in the control. So line edit here is very simple control. You just do set text to set the text, and then I can query text here on this part here. So here I can edit text like this. And I can get the text back from the control like this. So this is what you commonly see in normal applications in Windows. So these are the basic controls that you're going to use. And now I'm going to look at how you kind of construct your program to handle the user interface and your model. So you will create a model, which you are doing now, and you will create a user interface in a separate module, and how to handle the interaction between the user interface and the model, because we don't want to have a lot of the functionality of your code in the user interface module. You want to have all the functional application in your model that doesn't know anything about the user interface. So it's not important not to mix the user interface code with simulation models. and also handle the user interface model in a consistent way. And the reason also why we don't want to mix user interface code, it could be that next year when we're doing this course, we have switched from Qt to web-based interface. Then we don't want to be locked down into user interface codes. You can move your model to a different user interface library and still only rewrite the user interface part, and the model can stay the same. Usually what I do in my window classes where I present data is have a method called update controls that will take the values from the model, convert them, and display them in controls. And then I have a method that goes the other way around that takes the values from the controls and updates the model. So kind of a two-way link here. And there are things that we have or we will implement in the model is reading a model file of this that we don't have to rewrite in the user interface. We only have to select the files. And creating new models, that is everything will be built into that separate model that you're working with right now. So I will do a simple example here. So I have my model here. It has several options here. I have text value, option, alternative value 2. And I have so I can print it out here to screen. So this is my very simple model. And then I have a user interface like this. And then I have an update control here that goes from set text and takes my model text value and populates the controls. The thing is, if you have true or false values in your different alternatives that you can select in your model, you need to have an if statement here to check the appropriate controls. So this basically you set up the logic that goes from model to controls. And then the other way around, you have to check if radio 1 is checked, then I set model 1 is alternative 1, and so on. So then you separate which direction you go, from model to controls or from controls to model. So just to make an example, let's design a simply supported beam application. Very simple theory. And the idea we want to use it is that we create a simply supported beam object. Doesn't have any user interface. We set some properties. We initiate some loop variables, and then we can call our model here. It knows how to extract the sections, the section forces, and the moments. That's all built into our model. So I will go through it here instead. Looks like this. I try to be as rigorous as possible, so I have made all my attributes private with using the double underscores here. And then I have a function v here to calculate deflections. I have uppercase V for calculating the section forces, the moments. Then I also have something here that is a good idea. So when you have values like this, you get the value from the control. And if that is a text string, like an ABC, that doesn't convert to the floating point, I want to handle that. And what I've done here is I have a routine here that takes a new value, that is a value that could be a string, that is with an A, and then we have an old value that we keep. So, and then we do a try. If it doesn't convert to a floating point, I return the old value. Otherwise, I return the new value. And this way you can build in the conversion directly into the model. So in this case, I have implemented all my attributes here with properties. So A returns self A, but the important thing here is the setter. So when I want to set A, I call my toFloat here. And I give the self A here, my original value, as the old value. And if the V value coming in here doesn't convert, it will just assign A again. So nothing will be done. So you build in the error handling directly into the model. And we go on like this. Length is just a property here, so you can't set length. It just returns the A and B like this. And here you can see how you can run this. It just prints out a table of the beam here. So then we will create a user interface. Let's skip here. This is what we want to design. We have 5 text line edit controls, and then we want to display in the text box here the output from the calculation. So then we do user interface. And what we do, of course, we do a beam window with a Q widget. And here you can see here, I import my model here. Import beam model as VM. So now my user interface code has access to all the functionality of the beam model. First thing I do when I create a new window is create a beam object. A beam supported is my object here. I will keep that from the complete lifetime of my window. I will initialize my GUI. And then I have a update controls method that goes through, let's see here. You have a-edit equals set text self beam.a. And here I use, because the beam model always returns floating points, so I need to convert to a string using str, set the text. Then I have an update text edit here as well. That will populate, just fill the values with the table here. Then I have an update model here, which goes the other way around. So I take the values from my text edit controls, and now you can see the benefits here. The conversion is built into the model, so I can take the text here directly and just assign them to the properties here, and the conversion will be automatic. If it can't convert, it will keep the old value. So, but I don't have to do any conversion routines here. Only going from the values here to a string in this case. And then I also have, when you edit, there is a signal from the text box that is called editing finished. And then I do update model, I do update text edit, and update controls. So running this, let's see how it works. Did I put in edit that? So I can scroll here, and if I put A here, you can see here it just goes back to 2. So I can't put any wrong numbers here, and it automatically calculates. So editing finish is when you move between it will call the on edit finished and update the model like this. So I can do a larger force here, and you can see the table is updated automatically. So this is how you can think when you do design. So separate into different models. The model doesn't know anything about the user interface, and then the user interface, you don't have to have a lot of computational code in your user interface. Yeah. So this is model to controls, and then controls to model here. Now finally I'm going to show how you can, everything I've shown you today, we have done the control configuration completely manual. But you can use a tool called Qt Designer to create user interfaces graphically. And the reason for that is that when you get large user interfaces, there will be hundreds or 200s of controls, and you don't want to manage them completely manually in your code. So what you can do here is that you can design your user interface separately from your code, and then you save it in a certain XML file with a UI extension, and then the UI file can be read by Qt to create the user interface. You can also, there's a way where you can create special classes from the UI file, so you don't have to deliver your UI files to the user as well. But we are going to support the UI files here. And what you do is that you, instead of implementing your user interface separately, you use something called a user interface compiler, UIC, which you import. Then you do you load your user interface here, and then you tell the user interface compiler where you want to attach the controls. In this case, I want to attach them directly to my my widget class here. And that's it. Then you have all the controls that are in here are available as variables now. So the push button here is something that is defined in that UI file, and you can use it just like it would create it in code here. So I will try to implement a user interface. So let's see here if I can start. So the user interface of Qt Designer is here. Looks like this. So on the left side here, you have your controls. You can create a new window here. Just do a widget like this. Great. So this is your user interface where you can do the design. So what I'm going to do now is I'm going to create some buttons here. And then I'm going to just drag them approximately where I want them to be. So I want to have buttons on the left side, and I want to have some here on this side. So you don't have to be too precise. You just do like this. And here on the top here, you can see here that you have, this is the object hierarchy here, and these are the names that will be given in your code as well when you generate the UI file. And then I do like this here, and put some. So now I want to have a nicer layout. So what I can do now is I want to group them in vertical layout, and then I just select them here, and I click this button here, and you see they are grouped together in a layout. I do the same thing with these ones here, like this, and you can see here also that they are they have this vertical layout here, and these ones here are a horizontal layout. I click on this one here. Then I want to create a line edit here, or a text edit control in the middle here. I will go off this one here. So now I want to align them that on the top here I have 3 columns here with this layout here, the text box, and these buttons here. And then these buttons should be on the lower side. So then I just select all of these here like this. And then I say I want them to be horizontally laid out. Now I put this one here. Like this. And then the main layout now should be vertical. So I can select the main window here and assign the layout for the menus inside here. Then I select this one here, which is the layout vertical, like this. So now I have a scalable design I've created here. And then I would like the buttons here to be pushed up on the top. And then you can see here, instead of using add stretch, I have these springs here I can just add to my layout. So I click on the spring, drag, and I drop them here in the box on the bottom here, and you can see the spring goes up here. These will not be visible in the final design, so this is just kind of illustrating. And I want to kind of separate the middle buttons here as well. So I do this one here and drop it like this. So now let's see here, we call this one, this is my push button here. I will name it here to push button, we can call it my button here, like this. And I can, like this, and then I save this file here in my folder here, let's see. This one. let's say form11.ui, like this, same. So now it's called form UI there. I go back to my code here, and I have this form UI. So the difference here now is that this in my init GUI, instead of loading my creating my controller, I call UIC load UI self, and then I can see I call my push button here push button. I change it to my button here, and I connect it to my button here. So let's see if it works. Oh, I call it my button. Maybe that's why. My button. Okay, what happened here? So now I loaded my user interface from my UI file, and you can see here that I can change these things here, and the stretching works here. And you can see also that I changed my button here from my code here, and that this object was created for me in Python, and you can interact with it. So in this way you can create really complex user interfaces as well. And you can also do a new main window here. And here you can also create menus and create actions connecting to those as well. So Designer is a really good tool for quickly creating user interfaces. I have created a video on the site where you can look at exactly how to, when I go step by step to build the user interface. Let's go like this. So that was what I'm